Mat Kaplan of the Planetary Society here, continuing the second day of the Humans to Mars Summit here at George Washington University in the nation's capital. You just heard a fascinating panel, representatives of 4 companies, competitors, but all working together as partners on this grand effort to get humans to Mars. And you saw laid out a plan that looks like it may actually be able to get us there by the mid-2030s, let's say, 2033 being the sort of nominal target. Absolutely fascinating conversation, and we're going to continue that conversation with one of the participants. Charlie Precourt of Orbital ATK is going to join us in just a few moments, right after we watch, very appropriately, a video from Orbital ATK, one of the sponsors of the H2M Summit that is underway here today. So we thank them and the other sponsors who are represented by the other companies that you saw represented on stage just now. So we will be back in just about 3 minutes with Charlie Precourt from GWU, and let's go ahead and roll that video now.
Yeah, and I'm sitting there looking at my watch the whole time, and it says 11. But, for some reason, I had noon in my mind, and I know it's because Cheryl asked me one. Dragging me now.
Do you want me? I have to run pretty much over there to get there, but I do think that people probably do something in the logistics and what they got in people. You know, make sure right up to the right in the right and start.
And what time do we begin tomorrow? 8:45. Oh, they're laying off. They're easing up on it. Yeah. Okay.
Well, we overscheduled.
No kidding.
We've got to lighten up next year. Yeah. Well, we will have. You said this in a couple of emails.
We're back and expecting to have Charlie Precourt of Orbital ATK joining us momentarily. He's understandably been waylaid on his way here by all the... There you are. That didn't take long at all. Welcome. Mat Kaplan from the Planetary Society. Take about a half step back so that the camera, back this way, so the camera will have a better shot of you than of me. Great panel. I want to remind people of who you are, first of all. Vice President, General Manager of Propulsion Systems for the Flight Systems Group at Orbital ATK, and of course, a former astronaut, which is something I think that might come into the discussion a little bit. Let me start with asking you about this unique, I think it's unique, combination of folks on stage, which just before the video I just watched, normally we outsiders think of the 4 of you as competitors. I think you probably do internally as well. And yet there was a good deal of talk about the partnership that has come together among these 4 highly competitive companies.
That's true. And, you know, on SLS and Orion, we have our roles that require us to collaborate together. And we see a bigger picture in making sure that the vision is sustained and that the mission is supported. for the long duration, and our ability to work together to articulate that and to show how these pieces do integrate together and provide the necessary capabilities of the future. We all recognize that when those future systems come online, we'll be competing for them,
you tell
just
how many,
like you
might be-
mentioned.
Can you tell how many folks are online? How
We like
many
to call ourselves
individual-
competimates, and that's pretty true of a lot of folks in the aerospace industry. Is you team and then you compete depending on opportunities and capabilities, and that's what we've got now, though, is with SLS and Orion are the building blocks for exploration of Mars, and we want to make sure that we're solid together on that.
I like that term. I hope we can steal that from you. You spent over 900 hours in space. You've got a better idea than a lot of people, even the sophisticated group in this room, just how difficult this is. Mars is going to be hard. It's hard just getting robots there. Getting humans there, order to a magnitude harder.
Indeed, that's very true, and we talked about that some on the panel. And the only way I can relate it to people that need to be aware is we are doing well on space station. Scott Kelly just finished a year there, and a couple of Russians have done a year. And that's a significant accomplishment, but it was enabled by the ability to be able to send stuff up every 2 or 3 months to support them with resupplies of essential living requirements, new parts for machines that are not working. We've all seen the intermittent failures along the way. We suffered some pretty significant failures that almost involved the evacuation of the Mir station when we were doing Shuttle Mir. Those informed us as to how we would live on space station in a way that had redundancies to avoid those kinds of problems. But now we're going to take that whole system and put it where you can't access it for months and months and months, if ever, during the evolution of a mission to Mars and back. It has to be all self-packaged. Crew has to be able to survive with what it has. That's a big deal.
Very big deal. I mean, I think of just one of probably 1,000 possible examples. The problems that have cropped up, not lately, I don't think, but in the past with the solar arrays on the ISS. Parts had to be brought up from Earth, and people had to do EVAs. You can't get the parts when you're halfway to Mars.
That's right. There was actually a significant shift in the theory of how we were going to operate space station after the Shuttle Columbia accident. Originally, the space station was designed that the shuttle would be there for essentially its life to service the space station on a regular basis, and that parts would be brought up as needed and crews would be rotated as needed with the shuttle. When the shuttle went away and the decision was to transition away from it to smaller cargo vehicles and crew capsules that didn't enable us to bring big trusses up or big arrays up or big, heat exchangers and so forth. That meant that we had to pre-position stuff that could be there as onboard spares while we had the shuttle to carry those big outsized cargoes there. That's kind of the thinking we're going to have in spades when we go to Mars, is what kind of systems can be part of the package that are dissimilarly redundant, repairable, and we can have all that necessary equipment with us.
In the few minutes we have during this break, I would love to just be selfish and ask you all of my questions, but we do have a large online audience, and they were invited to send us questions as well. And we have one from Lexi, who would like to know what's being done to help astronauts deal with toxins like calcium perchlorate. Is this a concern? I guess this is talking about on the surface. Mars is a pretty toxic place.
Yes. And as we learned with the lunar surface, with the regolith and lunar dust, those were things that really caused havoc with the EVA suits that the crews used during the moon program. And so that will be part and parcel, simulating that environment with the equipment that we use to protect the crew is going to be part and parcel of the buildup to taking them there. I envision you'd have to have equipment that protects, but also systems that can clean those kinds of toxins from exposure to the crew when they're on the inside. So airlocks that are designed for that environment, suits that can handle that kind of equipment, and cleaning systems that can handle it as well. All be part of the development process.
One of the concepts that I think is fascinating that I know NASA is exploring is the spacesuits that don't have to go into an airlock. They hook directly up to a hatch so that what's outside on Mars stays outside on Mars. Is that something that may happen?
Exactly. No, I've seen those mock-ups underway, and they make a lot of sense. They expedite egress and ingress into the suits, and they keep the stuff that needs to stay outside. It makes a whole lot of sense.
Let me go back to one of the other themes that all of you talked about, but I think Julie Van Cleek may have stated most directly, and that is we saw all these slides that all of you were showing and these very sophisticated vehicles and these timelines. It starts to look like this is, for the first time, it starts to look like this is real. You know what I'm saying?
I absolutely agree with that. And I know in my own travels, speaking to different audiences about the space program, that you mentioned Mars 10 years ago, it was a faraway fantasy. Now we know from our experiences on space station that we have mustered a majority of the necessary technologies, other than the need to scale them up, make them more autonomous and reliable. There are no new inventions required at this point. It's a matter of putting together a system architecture that is survivable and reliable enough to get us there and back. And that's where the proving ground is so important, shakedown cruise, whatever you want to call it, that enables us to run through that entire scenario without actually being so far away we can't protect the crew. And then when we do step off, we've got a really sound system under us.
So you think with a continued commitment by, well, the public and the folks here within the Beltway in Washington, D.C., 2033?
I do. I actually believe that's very achievable. And I'll tell you what, when you look at the capability that heavy lift provides, if it's 6 missions in a convoy, that profile that we've shown from now to 2033 fits under a very modest inflation-adjusted budget plus about 2%. And so consider this, that for essentially the same human spaceflight budget investment we made from shuttle through shuttle and space station and now into exploration will take us to the surface of Mars and back. That is a pretty phenomenal accomplishment in its own right, to be able to do that much more on essentially the same budget profile, with a very modest bump for inflation and costs that we would see in the out years. So I think it's all very, very doable on that kind of timeline with the continuing commitment.
Charlie, they're telling me we're out of time for this break. We're going to get back to the program on stage. Thank you so much for taking a couple of minutes to join us again.
My pleasure.
Charlie Precourt, Vice President at Orbital ATK for Propulsion Systems, and a former astronaut, as you heard, Chief Astronaut, in fact. We are going to go back up to the stage, as I said, for another terrific panel. This one really looking at the science that we're going to be doing on the way to and maybe even living on Mars for a year at a time and doing stuff from orbit around Mars, perhaps as soon as 2028. So let's go back to the stage now here at the Humans to Mars Summit.